Breaking news. The solar system's most violent moon Io may have an underground ocean of magma. Craters, mountains, and valleys are common features on the surfaces of planets and moons, like Venus and Callisto. But one moon stands out, and that is Io. Io is a land of both fire and ice. It's extraordinarily smooth, and is the driest known object in the solar system. The heat near the volcanoes can reach some 1649 degrees Celsius, high enough to keep lava liquid, about 3 times hotter than hottest sunlit surface of Mercury. Io's surface temperature averaged at about -130 degrees Celsius, leading to sulfur dioxide snowfields. Io was discovered in the year 1610 and was named after the mythological character Io, a priestess of Hera who became one of Zeus' lovers. With over 400 active volcanoes, Io is the most geologically active object in the solar system. Io is also the innermost of the 4 Galilean moons of the planet Jupiter. Jupiter is the 5th planet from the Sun and the largest planet in the solar system. Jupiter is so large that all the other planets in the solar system could fit inside it. More than 1,000 Earths would fit inside Jupiter. The explanation to the unique features of Io are tidal forces. Firstly, Jupiter has a very big mass, and Io is the closest moon to Jupiter. The larger the mass of the planet and the closer it is, the larger the tidal force on the moon. This creates a huge tidal bulge in Io. The second reason is the eccentric orbit of Io around Jupiter. This is caused by the orbital resonance between Io and the other Jupiter's moon, such as Europa and Ganymede. Europa and Ganymede exert their gravitational influence on Io, causing Io to have an eccentric orbit around Jupiter. When Io is nearer to Jupiter, the tidal force caused by Jupiter is larger as compared to when Io is further away from Jupiter. Therefore, Io is constantly being stretched and squeezed, resulting in tidal heating. This is similar to what happens when you stretch a rubber band repeatedly. Notice that the rubber band becomes hotter and is being heated up. Model 1. The crust of Io slides over the mantle beneath. The interface between the 2 layers then liquefy, creating pockets of magma. However, the issue with Model 1 is that volcanoes don't occur where predicted, so there's a need for a new model. Model 2. There's a fully molten layer of magma in Io between the crust and the mantle. The tidal forces create weak spots in the crust, causing it to fracture, hence the constant eruption. So, Io's volcanoes are created via tidal heating. How different is Io's creation of volcanoes different from Earth? Earth's surface is made of both continental and oceanic plates. Due to plate tectonic movements, the plates may diverge or converge to form landforms, such as volcanoes. When a continental plate and oceanic plate converge, the converging mantle convection currents pull plates together and cause subduction of the denser oceanic plate. Magma formed by subduction creates volcanoes and granite masses in the overlying continental plate. The convergence of 2 oceanic plates can lead to the melting of the subducted slag, as the denser plate sinks, feeding magma to the island arm volcano above. Volcanic activity can also occur when 2 oceanic plates diverge. The diverging mantle convection currents push both plates apart, allowing magma to feed the mid-oceanic ridge. In conclusion, there are some implications to this effect of tidal heating. Now we know that tidal forces can heat up planets or moons. There's no need to depend on the sun as the sole source of heat, like on Earth. Since Io can have a subsurface ocean of magma, other icy moons and planets such as Europa and Enceladus can have a subsurface ocean of liquid water instead. These implications are significant. With heat and liquid water, there's a possibility that extraterrestrial life exists between the frozen crust of icy moons like Europa and Enceladus. Humans have always sought evidence of extraterrestrial life on the surface of planets and moons. But the physics behind these findings open up the possibility of finding lives underneath the crust. We can even be successful in our search for these alien life forms without having to exit our own galaxy.